Hey guys, welcome back. Hope you all are doing well. So today we are going to see LLMNR poisoning attack. Before going further, let's talk about LLMNR and why it is considered as insecure. So LLMNR stands for Link Local Multicast Name Resolution. If you see the name, if you notice the words, okay, you will find everything. Link local link local means it will work within the network or local network. Multicast means it communicate within the network with multicast, okay, and the name resolution means it is used for resolving the name. Fine. So link local multicast name resolution is a protocol that is based on the domain name system or DNS format, and it allows Windows machines to resolve host name on a local network segment without a DNS server. Fine. Even today in Windows 10 and Windows 11, this is still enabled by default because it can be used as a fallback mechanism if the DNS server fails. It is considered insecure because it lacks authentication, means for the responses it will not basically authenticate or verify the identity, and that's why it is considered as insecure protocol. So the purpose of this protocol is to resolve name in scenarios where conventional DNS fails and often used on local links. So when a system cannot resolve a host name via DNS, it multicast the request or query to resolve the name to all the machines on the local network, and any machine matching the name respond directly to the source. Fine. So as I mentioned, it is by default enabled in the Windows 10 and Windows 11 even today. So the security risk occurs here because LLMNR is not authenticated, and malicious actors can use tools like responders to trick machines into sending authentication credentials, enabling password cracking or network relay attacks. So let's see in very clear steps that how this whole scenario basically happens. So first of all, this is the victim, this is DNS server, this is our attacker. Fine. So first time, let's say the victim wants to access my share that we created in the previous video, but somehow he just misspell or the spelling is not correct of my share. So MYSH and he miss A and write RE. Fine. So once this request go to the DNS server for name resolution of this object or resource, DNS server will see and say, okay, I don't have any entry or I don't have any knowledge about this object, so I don't know where it is. So once DNS server fails to resolve it and the response goes to the victim, victim will say, okay, DNS server does not know about this. So the victim will multicast this to the local network. Fine. So you can see it goes to everywhere, and every node inside the network will receive this multicast request or query. Fine. Because the attacker, our attacker is also set within the same network, so the attacker will also receive this request, and attacker will respond by saying, okay, yes, I'm right here, I know where your share is, so please send me your credentials so that I can authenticate. And blindly this victim will send the credentials to the attacker. So the problem is here in this specific part where the attacker is saying, okay, I know where my share is, and the victim will blindly trust that response and send the credential. So this is the thing, and this is exploitable. So let's go. I already open up the lab here. So for this scenario, you just need one of the Windows 10 machine. Okay, so you can turn on any of these machines, just one we need. We need also the domain controller, and we need our Kali machine as the attacker machine. Fine. So also tune the resources, like you can, if you have less resources or limited resources, put the domain controller with 2 GB of memory and 2 processors. Put this Windows 10 machine also with the 2 GB of RAM and 2 number of processors, and put it Kali machine, you can put it 2 GB of RAM and number of processors too. Fine. So let's see. I already have Wireshark installed. If you did not install it, just go to your browser and write here Wireshark download, and with the very first link, make sure you are downloading from the trusted resources, not from the third party, because if you do this, you don't know which Trojan you are downloading. So just go to the Wireshark side and download the very first one, Windows x64 installer. If you want portable, you can go and download this portable also, but every time you have to execute this to run the Wireshark. Also, this package, portable package, does not come with the NP-cap, okay, network protocol capture. So you need to download the NP-cap or P-cap from different sources. So it's better you install or download this one and install it. So just click on it and it will download it. So once you download that, put it on your Windows 10 machine. Let me just show you once so you know it better. Okay, so I have it here. I'm gonna paste it here. You just need to double click on it. Yes. Yes. I want to uninstall it first and then install. Okay. So let me just go back. Okay, this is the first one. Noted. Next. Okay, leave it like this because we just need the network protocol analyzer. We don't need to trace USB or Android things. And make sure these boxes are checked. Go to next, next, and here you will find one option where it will say, okay, install npcap. So this setup file comes with npcap. You just need to check this box. Okay, once you install it, just check this box. Next, and leave it like this because we don't need to capture the packet from the USB, and also just install it. Okay, the whole process will be like this. Next, and finish. So we have Wireshark now. So we already know about the LLMNR now and how the poisoning works, but we need to see it in action. Fine. So here you can see we will see basically how LLMNR works in action. So we go back, start the Wireshark. Okay. Fine. So I have Ethernet 0 on this machine and you can see there is a traffic. Fine. So I'm gonna start capture here and then open the file explorer, and inside the file explorer just write here something like my shre like this or whatever name that does not exist. Okay, hit enter or click this arrow button. You can see here LLMNR is now appear. Okay, so this traffic appears. Fine. I just need that. Now just stop the Wireshark, stop the capture, and I will go to the LLMNR. Or you can, if you have a lot of packets here, a lot of traffic here, you can filter it by saying UDP dot port equal 5355. Hit enter. Oh, sorry, I made a mistake. UDP, not UPD. Fine. So you can see now LLMNR packets are here. If you, this is for IPv6, so we will just consider IPv4. So just click on this packet and you can see here link local multicast name resolution protocol query appears. Just expand it and you can see it's asking one question. What question it's asking? Go to the query section and you can see it's asking for my share. Where is my share? Type A. Type A is the host record. If you see here type 4A, that means it belongs to IPv6. Let me show you. Here you can see 4 times A. That means this is also the host record in DNS, but it is for IPv6. If you expand this, you will find here IPv6. but for here you will find here IPv4 type A. Fine. So it's basically querying by multicasting to all the nodes in the local network. Where is my share, or anyone know my share? Now, how do I know whether it's doing it from multicasting by multicasting or what? So if you see the source, this is the source address, which is our victim machine, means Windows 10 machine. So if I just try to see the IP address, IP config, you can see 131. This is our IP address. So this is the source, and destination address is 224.0.0.252. So if you know about IP subnetting and you know about the IP classification, so you know that if the address start with 224, that is reserved for the multicast address. Okay, so this is the multicast address. That means the victim or our machine, Windows 10 machine, is multicasting this query to the local network. Now, because no one here in the local network to catch that or to capture that query and respond to that query. No one is there. Okay. So what if an attacker is there in the local network and he just use a tool that is used to capture LLMNR, NetBIOS name service, DNS and DHCP queries, and then it is capable to respond or spoofed their identity or masquerade themselves and then respond to these queries. Okay, so responder space -h to see the switches, what switches are there you can use. So you can see all these are the switch. Like here we have space -I stands for interface. So our interface is ETH0 most probably, IF config, or you can say IP space A, like this. Okay, so in both ways you can see ETH0 is the is our interface, and this is our IP of Kali machine, and LO is the loopback interface that we don't need. So Ethernet 0 is our interface. Fine. These are the switches we can use for the poisoning option. If you want to poison for IPv6, you will choose -6. Okay, DNS, SSL, hex, name, all these are the options there. But we are going to use what? We are going to use WPAD for the proxying, and we will use -v for the verbose, this one, and we will also use -d. Okay, so DWV we use. I'm gonna clear it and go back to the responder. I'm gonna say space -I. My interface is ETH, come on, ETH0 space -d, W and V for verbose. So proxying with WPAD, and verbose will give you more explanation or more detail. Okay, just hit enter to start the responder, and you can see these are the poisoners. So you can poison LLMNR, okay, NetBIOS, MDNS, DNS, DHCP, DHCP version 6, and these are the servers available with the responders. Okay, WPAD, auth proxy are there, SMB server, Kerberos server, SQL server, HTTP, HTTPS. Fine. And you can see it found DHCP server IP and now waiting for incoming request. Although this does not belong to us, this belongs to VMware. Okay, so no worries, just keep an eye on this. Go back to the victim machine. Now let's see, I'm just going to again restart the capture. So continue without saving, so it will start new capture, and go to the file explorer, and let's just behave like a victim, and the victim try to search my share and he misspell this word my share. So instead of MYSHARE, he write down my SHRE. He missed A. Okay, hit enter, or you can just click on this arrow button. Okay, go back to the responder, and wonderful. So you can see Nobita blindly send his credential to the responder. Why? Because responder, once the broadcast is, or once the multicast is started, okay, by the victim, okay, so our responder cache that request also, capture that request also, and respond falsely by saying, okay, I know what you are looking for, please give me your credentials so that I can authenticate you. And without verifying the identity of responder or our Kali machine, Nobita or victim machine just send the credential to the responder or to the Kali machine. Fine. Okay, so that's the thing. Now, if we come back to our test one machine and close this, go back to my Kali machine, and let me just now cancel it, Control C to exit, and back here. Now we will analyze one more time these LLMNR. So I'm just going to hit on this filter, and all the LLMNR requests and responses are here. Now, this is our victim IP, okay, and this is the hacker IP, okay, because our Kali machine IP is 192.168.115.134. So this is the query. You can see link local multicast. I don't need this. Okay, link local multicast name resolution query, and the query is the victim is looking for my share, and this is the response. In case of response, the Kali machine will be the source and the victim machine will be the destination. So if I show you this, in this case, because the packet initiated from the attacker means Kali machine, so it will be the source and the victim machine will be the destination. Fine. Okay, this one. So once you click on it, you can see now this time it also contains the query and also contains the answer. So if you see the answer, so our Kali machine responder is saying that, okay, my share has this IP address. I know that my share, but you need to send the credential for authentication. So our victim machine, Nobita, just send the credential. So this is all happened under the hood. You see everything now in action. So this is the request where our machine, our victim, trying to access my share, multicast it. You can see multicast it, and this multicast reached to every node inside that local network, and also it reached to the attacker. Then attacker capture that and see, you need my share. So okay, I have it, and just this is the address of it. Send me your credential. Okay, fine. So that's it. Now what we can do, we have the credentials, but the hash credential of the Nobita user. So what attackers can do, they can take this hash, okay, and just copy that, and I'm gonna open here, create one file, nano, let's say the name is hash, and I'm going to paste that hash. So you can paste it with Control Shift V, or you can just right click and say paste. Okay, now to save it, just Control O and enter and Control X. So if I need to show you that cat hash, you can see this is the hash what I copy and paste it in a file named as hash. Now we need to crack that hash. So I'm going to do it with John space hyphen W, or we need to specify the file name, which is hash, and I need to use a word list. So space hyphen W means the word list slash user share word list, and the word list I'm going to use is rocku.txt. But you can see this rocku.txt also have one more extension which is .gz. That means it is compressed and I did not uncompress this file. So whenever you install a Kali machine, okay, fresh Kali machine you install, this file basically comes in the compressed form. So you need to uncompress it. So just open this, okay, file explorer, open folder, go to file system. You need to go to USR, then share, Then you need to write here word list, and you can see this is your word list, and this is roq.txt .gz. That means this file is compressed. So just right click and do extract here. Okay, it will take a little bit time and then it extract this file. Okay, now this file is extracted. Come back here again. If I just write roq, you can see roq.txt is here. Fine, and just hit enter, and in a moment you can see it cracked that hash, and now we know the password of Nobita user. So the password of Nobita user is password 1. Make sure you create good notes, because if you forget anything, you can go back to the notes and verify it. Okay, so I'm just gonna write it here. Nobita has a password of password 1. Fine. Okay, now the next thing is, we know the password and now we have the initial foothold. Now you have to find out a way to enter into that machine, which is 192.168.115.131, I think, which is the test1 machine. Okay, cmd ip config 131. Yes. So if this machine has remote desktop enabled, let's see, remote desktop settings. Okay, and enable it. Confirm. Yes, it's enabled. So if this machine has remote desktop enabled, you can access it. Okay, like if I do, okay, I'm gonna say mstsc. I'm gonna write here the IP address of the target machine 192.168.115.131. Hit enter, and now it will ask you for the username password. So I'm gonna say Nobita is the username, and the password is capital PASSWORD 1. Okay. What I write wrong? Capital PASSWORD 1. Okay, maybe the problem is we need to access like this, because our domain name is test. So test/Nobita, like this, and capital PASSWORD 1. Yeah, this is the way. So you can see we get the remote desktop session. I'm going to create a folder to verify. Okay, hit enter, and now I'm going to disconnect from the remote desktop and go back to our VMware machine, local machine from the VMware, test1 and password 1. Hit enter, and you can see that folder is created here. So this is how attackers get the initial access into your domain environment after the scanning, reconnaissance, and information gathering. This is the very first step to exploit something and get into the environment, which is initial foothold. So now you have the initial foothold in the environment, and you have the password of Nobita. Once you get the initial foothold into the network, okay, or into the environment, it could be as low privileged users or standard users, or it could be domain admin also, because maybe instead of Nobita, Doraemon, which is our domain admin, maybe he is logged in and he just misspelled to access some kind of share or access some kind of machine or service. But once he misspelled, we get the hash of the Doraemon. Okay, so that's it for this video. I'm gonna see you in the next video. If you like the content, please like, subscribe, and share. See you. Bye.